All right.
Boleh nampak ke saya share?
Boleh.
Okay. I think boleh start now.
Okay, so that now. So hello everyone. So this is our third and the last engagement meeting with our industrial mentor, Mr. Ashraf. And today our agenda consists of the revised PFD and process description of hello, can you hear me?
Yes.
All right. So today our agenda consists of revised PFD and process description of centralized heating by Team 20, and also the pool profitability analysis, pool environmental or sustainability benefit, as well as the pool plan layout. So next slide, please, Amma. So without further ado, we will start with the revised centralized heating system, and I'll pass the floor to Team 20.
Hello, can you hear me?
Yes.
Okay, so for the revised centralized heating system, next. So this is our finalized PFD of the heating system. So at first we had two PFD, but we decided to use the original version because of several factors. So one of it is because it consists of the lowest equipment, and also because of in consideration of the cost. So this is our PFD. So next, so in our PFD, the summary of equipment and installation. In our PFD, it consists of 9 equipment. So the first one is the steam boiler that is identified as R21, 201. Sorry. The function is to produce HPS at 50 atm and 300 degrees Celsius. So inside the R21, it consists of furnace to produce exhaust gas from fuel combustion to provide heating to the steam boiler. The next equipment is pump P201 to increase the makeup water pressure from 1 atm to 5 atm before entering the deaerator. The next is pump 202 before entering the boiler R201 to increase the feed water pressure from 5 atm to 50 atm. So the next one is compressor K201 to increase the pressure of steam from 50 atm to 55 atm before supplying to consumer, which is in this case is actually to provide to give the steam to team 16 and team 19. So the next one is condenser C201 to condense the steam returned from vapor to liquid. And also the last equipment is the aerator D201 to remove the oxygen and other dissolved gases from liquid and flammable compounds. So in any way, the aerator is also to reduce the corrosion in the pipeline. So next one. The next slide. Okay. So from our from our calculation, this is the summary of mass and energy balance. So in this equation, the basis is actually at the stream 8, that is 4,529.13 kilogram per hour of water. So from this calculation, we can get the value of the stream. So if you notice, the stream 2 is actually the total amount of required of HPS for our pool. So and then the next one is to calculate the heat duty. We need to identify the enthalpy. So the enthalpy is actually determined using the superheated steam table. So by multiplying the enthalpy and the mass flow rate of water, we can get the
will present profitability analysis of our pool. First of all, I will introduce the comparative analysis between non-verbal and verbal. Non-verbal consists of two types, which are first, purchasing, and second is plan system. Meanwhile, the verbal is the centralized one. Non-verbal, meaning that each chemical plant purchases on own utility rate from utility company. For example, cool water, chill water, electric, and waste is sent off site for treatment. For non-verbal plant system, each production plant will build their own utility and waste plant. We have 5 production plants in our pool, so each of the plants will have their own utility and waste treatment plant. So we need to calculate the capital operating cost for each of the production plant. So for verbal centralized, the 5 production plants share one centralized utility and waste treatment plant. So we actually can save off money, sustainability, and environmental needs. Moving on to the raw material, we realized the cost reduction from 8 billion, 8.6 billion ringgit per year to only 3.1 billion ringgit per year. And this year, we reduced the amount of the material cost to 64% or 5.5 billion ringgit. This is because the CO2 produced from Team 18 is used by Team 17 to produce ethylene glycol. The CO2 produced, we supply ethylene glycol because ethylene glycol has higher market price than ethylene, and because we want to maximize the profit output, then the acrylic acid produced from Team 18 is completely supplied to Team 19 from Team 18 to produce late because putty acrylic has higher price than acrylic acid. Moving on to logistics and transportation, is the that we can save about 40% or 69 million. This is because all raw for non-material from supplier and it is transport truck because the production plants are distributed not in one place. They are distributed and dispersed in different places. So they are transported through truck. While the verbal centralized, the byproducts of one process are used as starting materials for another process. Pipeline is majorly used as transportation mean. This is because the 5 production plants are located in one centralized place. For example, we can see the simple example from the Pengerang complex, which is a large complex consists of 3 plants where they implement the verbal centralized system. In terms of labor, we actually can save 6% or 15.5 million save from in the non-urban. We use 1,000 labor, while urban only use 636 labor. The non-urban on plant requires first at each production plant for utility and treatment system. So a lot of labors with when we implement the non-urban, while the centralized utility system. So centralized system require labor to work. Okay, moving on to the centralized utility or waste system, we can save 77% reduction or 6.9 billion. Okay, this is the comparative analysis between verbal and verbal centralized. The verbal centralized rank the lowest for centralized system because it requires less fuel as emission are produced. While for non-verbal purchasing, the cost rank the non-verbal purchasing rank the highest cost because utility purchasing and transport is expensive. While verbal on plant system, the cost is moderate because the more cost for the fuel, turbine, and compressor utilities. For the total BAR module cost for equipment, overall equipment, we realized the reduction of a total 1.6 billion ringgit or equivalent to 41%. Moving on to the overall analysis. Okay, so the total cost, which consists of two costs. The first one is total capital investment, TCI, which consists of total direct and indirect costs, fixed capital investment, working capital, and startup costs. It basically tells us the capital expenditure, the one-time expenses to build the plant. While the total annual manufacturing expenses (ANE) consists of direct production costs, utilities, waste treatment, and miscellaneous. When we compare before Verburn and after Verburn, we actually can save a lot. With after Verburn shows the lower cost for TCI and ANE compared to before Verburn, and we can obtain net annual profit higher for after Verburn than the before Verburn, which approximately 6.9 billion ringgit, and as well as after tax rate of return ROR. For payback period comparison, after Verburn provide a shorter payback period for undiscounted and various discounted discount rate, which are I equal to 3% and I equal to 5%. So for undiscounted payback period, after Verburn shows from only 2.95 years, which means that we can get the profit in a shorter time compared to before Verburn, which requires a longer time to get the first profit. As well, this is also implies to maximum discount rate of 20 years payback. For the cash flow graph are included in the appendix at the end of the slides.
Now moving on to the environmental and sustainability benefit for our pool. Next slide. So for the first one is the energy saving from heat exchange. So after each of our plant do the heat integration and installing heat exchanger, we get a 55.66% reduction in energy saving, which is from 1,141,803 kilowatt to 506,275 kilowatt. Next slide. Second one is for carbon footprint reduction. So for this part, they have three parts, which is wastewater emission, energy emission, and transportation emission. For wastewater emission, we obtain 100% reduction. This is because the wastewater that we treated will be given to Team 17 as their raw material. So meaning that there will be no wastewater that have been treated is discharged to the environment. And then second one is the energy emission. So for this part, we just use the data from the previous slide. And then from the reference that we refer, 0.693 kilogram of carbon dioxide is emitted per 1 kilowatt hour of energy required. And then the last one is the transportation emission. So from what Amar mentioned earlier, before Verburn, we assume that all the raw material will be supplied by supplier and the mode of transportation is truck. And then after Verburn, some of the raw material for plant is obtained from other plant. So that raw material is transported to through pipeline, and the amount of carbon dioxide emitted for pipeline transport is lesser than by using truck. So that is why we get 65% reduction for transportation emission. Next slide. Okay, now how do we relate the environment and sustainability analysis to SDG? So first one is the clean water and sanitation. So for this SDG, it is focusing more on the wastewater, because one of the aim in SDG 6 is to reduce the amount of untreated wastewater dumped to the river. So when we have the centralized wastewater treatment, we significantly reduce the amount of wastewater produced in our plant. And second one is the responsible consumption. So for this SDG, uh, one of the main important things in this SDG is to reduce the waste generation through recycling and reuse. So after we apply Verban concept, some of the unwanted chemical compounds can be recycled back to be used for other plants. So it directly reduce the amount and also reduce the amount of waste generated in our plant. And then lastly is SDG 3 and 13. So these two SDG is focusing more on air emission. If the amount of carbon dioxide emitted in the atmosphere reduce, it will prevent climate change, and it will also avoid any disease that related to extreme weather change, such as heat stroke. So that's all for SDG. Next slide. Okay, so from our wastewater and then waste and air emission that we generated, we are focusing more on carbon dioxide emission. This is because if we refer to the graph on the left side, we can see that the amount of CO2 emission in 1900 increased significantly to 2020. And because of that, the temperature also increases as the CO2 emission increases. So we want to help reduce the carbon dioxide emission in the world. Next slide. So that is why we choose carbon capture and storage as our ways to handle carbon dioxide emission. So for CCS, if we take from what European Environment Agency said, they mentioned that the emission of carbon dioxide in the Europe would fall by around 60% by 2050 if CCS were implemented at all coal-based power generation plants. And then taken from Equinor, which is an energy company in Norway, they said that CCS is recognized as an important proven technology for reducing greenhouse gas emission around the world. So we believe that CCS is one of the ways to help reduce the amount of carbon dioxide emitted in the atmosphere. Even though the cost might be expensive, but if we can imagine what would happen if the amount of carbon dioxide increase every single day, I think we might choose to use this technology instead of having to handle such high amount of carbon dioxide in our atmosphere. And then for CCS, usually they will inject the CO2 that we obtain, but actually the carbon dioxide also can be sold to cement industries. This is because the CO2 can be used for CO2 mineralization process. So in this process, it can make the cement strength become stronger, and because of that, the cement we might need less cement, and also it will reduce the amount of emission from the cement. So to summarize about the CCS, although it might not as famous and it's very expensive, but the design is as sustainable as advanced countries such as Australia, Denmark, and United States. So although Malaysia is still in the proposal stage and has yet to implement CCS, our pool are positive that this technology will become a subject of much interest in the future. As a result, we must arm ourselves with the developed sustainable process to address the environmental issue from now on. I will pass on to next team to present.
Hello. Mm, hello.
Yeah, I can hear.
Oh, can go to the slide. Okay, I start. So this is the overall plan layout which we consider in terms of site safety, logistics, and which one is the most economical. So the layout will be divided into two areas, namely the yellow one is the non-process area and the blue one, the process area. And since this is an integrated plant, the plant will share common facilities like a centralized lab, workshop, and waste handling area. Next slide. So the yellow regions and the blue regions are separated of more than 30 meters apart. So due to the plant dealing with hazardous process and for safety considerations. So the canteens are located near the administration office but far from the process area to reduce time personnel spent and to protect of contaminations of food. And the plant domestic waste is located near the site entrance. It is located far from the plant to avoid traffic in the plant area and to prevent like disturbance from the unpleasant smell. And the chemical warehouse is located further away from the process area to minimize the loss in the event of a fire. And it's also located near the driveway so the tankers can easily access to them. Next. The administrative building consists of the HR, finance, technical services, CEO, training room, and prayer room. And the medical center is located at the border of between the yellow and the blue regions so that it can provide immediate emergency protocol if there are any injuries. And security office are located at both entrance and exit to prevent any trespassing. So overall, in the non-process area, the dimension implemented with an average of 10 meters apart to minimize space and time spent to travel from one building to another. Next. Next is the process area. So as recommended, the distance is usually at least 30 meters from reference, but we implemented a distance of 50 meters as greater space is needed for like hazardous process. So team 16, team 20, and team 18 are grouped side by side since they require use of the raw materials. And team 20 is located near team 17 since it will supply some of its ethylene oxide to further process into ethylene glycol. Same goes for team 18 who will supply some acrylic acid to team 19 to process into butyl acrylates. So the future expansion is allocated for each team and the plant for purpose of business expansions where maybe a new cluster or more volume of chemical is required, and this will help in increased production capacity of the plant. And the building in the plant area are single story, which help cut costs, provide flexibility in layout and production routing, and also require less supervisions. In terms of utilities, so the wastewater treatment used to treat the wastewater produced by team 18, 19, and 20, and the treated water will be recycled back to team 17 for the productions of ethylene glycol. So the wastewater treatment is located near team 19 as that plant produces the largest amount of wastewater. And all team will utilize the cooling water, and team 16, 20, 17 will use the stream from evaporator. The core utilities are located near the plants that require the most. Boiler system is located nearest team 16 and team 19 since only these two require it. Team 17, 18, and 20 produce waste gas mostly contain carbon dioxide, so the air emission carbon capture and storage is located near the three processing plants. And lastly, assembly area is located near the main entrance for evacuation during emergency. All right, that's all from me.
In short, next slide, yes. In short, the raw material, logistic, labor cost, total bare module cost, and also the payback period are reduced after the Woven concept applied. Besides, it also provides more environmental benefits in terms of energy saving and carbon footprint reduction. The integrated plant also provides the in-house facilities with smaller plant area, and this can conclude that the Woven system provides more benefit in terms of economic and sustainability. So that's all from our pool. So Mr. Ashraf, if you have any question, please please do so. Thank you.
Okay. Thank you very much. Very good presentation. Well structured. Well, your slides are very well organized and well structured. I have few minor comments. Perhaps maybe we can go to the summary of mass and energy balance for centralized heating system. Okay, this one. I just want to ask whether in your economical analysis, because you know, right, your centralized heating system, your main cost is would be your fuel lah. Because and what type of fuel are you using for this heating system?
We use natural gas methane.
Okay. So as you can see in your summary of mass energy balance, the main activity is heating from stream 5 to 6, right? So you're heating from 38 million kilojoule per hour to 297 million kilojoule per hour. So basically, you need equivalent heat of around 258 million. So my question is, when you do your cost analysis, cost calculation, your fuel equivalent is based on this 258 or no, or not?
Can repeat, sorry, can repeat the question?
My question is, in your cost analysis for this centralized heating system, for your fuel required annually, is it based on this heat requirement of 258 million kilojoule per hour or not?
Yes, we consider that one.
So meaning you're considering your boiler is 100% efficient.
90.
So meaning if 90, because why I'm asking is just to confirm that you get it right in your cost analysis, and so that you will be able to answer correctly to your examiner. So meaning the heat required is 258. So when you consider your boiler efficiency is 90%, so it's 258 divided by 90%. So it's equivalent. Your fuel equivalent should be 287 million kilojoule per hour, correct?
Yes, correct.
So your cost analysis is based on this heat value.
Yes, because we want to calculate how much fuel.
Okay. Okay, good. Just to confirm. Can we go to your plan layout? Just a few comments. Normally for this big complex, because you, in fact, in your slide also you mentioned, right? Where was it? You mentioned something about in case of fire. Anyway, for a complex this big, normally you should also include your own fire water tank, right? Your firefighting system, your own ERT system.
Yeah, I think we missed up the fire station during editing the layout.
Yep. Just take note on this. It will be good if you can include before your presentation, because it will be practically be more realistic Because I believe you had visited most of the petrochemical plant in Malaysia, right? And you can see that most of the plant with such big complex like this, they normally have their own ERT and their own firefighting system and fire water tank. So by right, you should allocate one area for this. My second comment is it realistic for you to combine laboratory and your workshop? Because this workshop refers to your maintenance workshop, right? And laboratory is where you test your daily, your QA/QC of your daily product.
We just put that one as like one unit,
Yep, but
like
normally
near to each other like that actually.
Yep, but normally if you visit other plant, you cannot. They are not near to each other, because you need to consider workshop is it's a workshop. People do maintenance, people do heavy works. So I'm not sure if it's realistic for you to combine laboratory and workshop together.
All right.
And where is your equipment spare part warehouse? Your inventory?
We did not
Yep.
consider that part yet.
Yep. I suggest that you include this also to make it look more realistic on your plan layout.
Okay, sure, can.
Also, maybe you can, of course, your legend, maybe you can include also the legend for each of these dash and different color line. My question is, apart from that, my question is, I see the dark blue line refers to the CO2, right? That goes to the carbon capture and storage. The blue dash line.
Yes. Team
So,
16, 18, and
so you're capturing CO2 from team 16, team 18, team 20, and team 17.
yes, correct.
You're not capturing CO2 from your boiler?
No, we did not consider that yet.
Will you consider? Because you're emitting
because
CO2 also from your flue gas, right?
oh, okay, we considered that, but we thought because the boiler is quite can consider small, so I thought no need. But since we will do it,
No, because I'm pointing it out because this can be one of the question from your examiner, because when they see CO2 is being generated not only from the plant but also from the combustion gas from your boiler. So you just need to be able to justify why you did not consider CO2 from boiler. Maybe it's not economical to absorb additional cost for the CO2 capture from your boiler.
okay.
Other than that, I think everything is quite clear. Everything is good. No further comment from me.
May I ask question regarding the first comment? The fire water station,
Yep.
where is suitable to locate that in this plan layout?
Normally you can put actually normally it's quite near to your admin office or your car park. It should be, because your fire station needs to be near to the access to the plant. So it can be either from to next to your admin office where you have plenty of space here, or you can put at your expansion area, the expansion on your top right. Because normally bomber requires it to be near to any access.
Okay, for the second comment,
Yep.
The laboratory and workshop. So right now it's combined into one unit. So if we break down into two, which means the lab is here and workshop is down here. Is it okay?
Yes, it's okay. So normally workshop should be near to your spare part inventory lah, your warehouse, your spare part warehouse. Because here you only put your chemical warehouse, right? Normally you should also have your warehouse for your equipment spare part for maintenance purpose.
So spare part warehouse are nearer to workshop.
And also your domestic waste handling area, I suggest you put not only domestic, maybe you can split it into domestic and also scheduled waste, because I don't see your scheduled waste handling area in this plan layout. Because you will definitely generate scheduled waste daily, because for example, the easiest example is the grease that your maintenance team are using for daily preventive maintenance. So definitely yep.
Okay, meaning that there are three zones lah.
Yep.
So first the yellow, the blue one here, and also the domestic scheduled waste.
Yep. No, domestic waste and scheduled waste. Scheduled waste is specific to any scheduled waste that you generate in your plant now.
So 4 zones in total.
Yep.
May I ask the domestic where to locate it?
Domestic you can maintain here. Scheduled waste normally you can put near to your inventory. Yep. Yep. Or you can put your scheduled waste near to your wastewater treatment lah, because normally scheduled waste storage area you require to have some. It needs to be equipped with a facility to capture any waste, and in case of this waste runoff, it will be directed to your wastewater treatment plant. So maybe you can put this near to your on the left bottom side lah.
Okay, so this for plan layout. Plan layout okay, settled. I would like to ask for profitability analysis. Is it logic for before Verburn to have only 2% maximum discount rate of 20 years payback?
Yeah, it
And
makes
also
sense. It makes sense because even if you can compare with your undiscounted before and after Verburn, right? You have almost 11 years difference, right? Yeah, right. So it makes sense. So normally if your examiner asks, so normally because you have these three criteria, right? You have 4 criteria, right? At 0%, 3%, 5%, and 20 years. So normally the realistic one would be 5% lah. 5%, because 5% is consider the interest rate being imposed by if you are taking if your project is being funded by bank, or if your project is being funded by some company like Petronas is funding your project. So normally the range is between 5 to 10%. So normally this 5% should be a realistic reference lah.
Okay, I see. Yeah, I think. Anyone have any question?
No, for me actually.
So for plan layout, equipment inventory tu dalam blue area ke?
Blue area. Dia part of your you can put next to your workshop.
Another question. Oh, okay. So this one is for complex, right? So it needs to have the fire and water station.
Yep.
How about if we consider the non-urban system for one plant, is it needs to have a
No.
water station?
Non-verbal, dia actually depend on the size of your complex. So if it's dia actually ada to see whether you require your own fire water station or not, it depends on the size. There are several criteria being imposed by BOMA. So, but normally what I can say, if you only have one plant, I don't think you require a fire water station. If you have one individual plant in their own perimeter. Because the main determining factor is it actually ties back to your hazard analysis, how much, what is the quantity of hazardous chemical that you store, how much hazardous chemical or flammable chemical that you are handling daily. So based on this, you do the analysis, then only you know whether you require your own fire water station or not.
Okay. Another question I would like to ask.
Yep.
Yeah. From the rubric guideline, it says that the layout should consider appropriate scale of land area. Ni macam tak faham sangat. Yang ni maksud dia dimensi ke?
Dimension, betul.
So dimensi kat sini logik ke, Cik?
Tu susah tengok sebab and you kena calculate lah. Normally you just need to show your overall layout je, overall layout punya dimension.
So like macam kita buat 100 meter, 50 meter.
Ni distance kan, distance between plant kan.
Yes.
So you kena kira overall layout. You don't need to measure for each. It will be good if you can measure for each plant, tapi normally you just need the overall layout. Overall dimension.
Last one question. Kalau yang CCS tu, saya risau kalau dia tanya, Thailand tanya, yang ni kena ikut guideline. Maksudnya apa? Apply to apa guideline? Saya cakap.
Tak ada.
Malaysia punya rules regulation.
Malaysia pun tak ada guideline lagi.
Kalau macam macam flare tu, dia dah ada guideline dia kan?
Betul.
Betul.
CCS Malaysia tak ada guideline ni. Malaysia sebab dia even sebab before ada guideline untuk CCS, Malaysia kena impose CO2 tax tu. CO2 tax pun Malaysia belum impose lagi kat for local plant. So basically at this stage CCS ni more on sustainable punya initiative by respective company. Yep. It's a means of preparing ourselves for the future policy. Sebab as of to date, Malaysia target at least 30% carbon reduction by 2030, and then by 2030 probably they will impose the carbon tax. Tu pun belum confirm lagi. So you can say lah, this CCS is part of your sustainable initiative.
So kalau panel tu macam dia tanya balik, yang ni cost dia mahal, so kita cakap yang ni kita lebih care pasal sustainability environment.
Betul. But sustainable cannot be actually sustainable. The sustainable initiative with respect to environmental, it cannot be considered as part of your profit punya analysis lah, sebab it's your macam you punya goodwill kan. Yeah.
Satu lagi Encik, pasal kita orang buat GCC Grand Composite Curve tu. Lepas tu untuk cooling utilities kan boleh generate LPS kan.
Yup.
Bila generate LPS, kat dalam ni dalam pool kami tak ada pun tim yang perlukan LPS. So
betul.
kami jual kepada orang luar, company luar. So kita kena consider ke storage line.
Yup. Pasal tu kalau you cakap you jual tu plan luar, PFD ni kena berubah lah. Sebab dalam PFD ni all the LPS you terus condense to combine with your boiler feed water kan.
Tak, yang ni kami tak consider LPS. Yang ni HPS. Yang LPS.
Yelah HPS, after HPS to being consumed, you will, before being sent to condense is in LPS or sebab dia 165 kan, 165 ni dah LPS kan.
Okay.
Kan. At 355 ATM tu memang HPS, tapi bila dah consume, dia dah condense, dia dah release the heat, dia 165 at 5 ATM ni dah LPS lah. So since you cakap you tak ada LPS consumer in your plant, you just boleh mention lah you no user kan, so you just convert it back to condensate and combine with your boiler feed water lah.
Kalau combine tu akan berubah PFD ke?
Tak, kalau dia akan berubah kalau you mention you akan jual kat external party.
I see.
Sebab kalau you nak jual to external party, you punya stream 2 ni will not be 100% going to the condenser lah. You need to branch out another line and going to external consumer, and then you need to mention how much are you going to sell everything, or but kalau you sell everything, so you punya boiler feed water will increase lah. But sekarang ni you consider part of the boiler feed water is from stream 3 kan, so stream 3 plus stream 8 will be your stream 4. So kalau all of your stream 2 is being sold to external party, so your stream 8 will increase lah to compensate. I suggest at this stage you just maintain like this lah. You just say that since you don't have any LPS user and you can say lah it's not economically viable for you to invest to supply LPS to external party, so you just consider all the condensate return from team 16 and team 19 are converted to combined with your boiler feed water. Or else banyak kerja lagi you buat You kena revise everything. You kena revise balik you punya cost analysis. You kena revise balik you punya profit analysis.
Itu je kot cik. Dia dah tahu apa dah.
Okay, good, very good.
Request daripada Cindy nak ambil gambar.
Nak ambil gambar tak? Last kali sudah.
Boleh.
So, everyone please open the camera. Let us have a final photo session. So let me count. 3, 2, 1. And another one. 3, 2, 1. All right. Thank you, guys. Thank you, our industrial mentor, Mr. Ashraf. So, I think we can end our meeting here. So let's work hard for the final presentation. Thank you, guys.
Thank you very much. All the best.
Thank you,
All
sir.
right. Thank you.
Okay.
Thank you.
Kalau
ada kerja kosong ni Raja.
boleh. Connect lah kat LinkedIn.
Nama apa?
Here there.
Ashraf lah,
Sir.
Ashraf Tariq Anwar.
Oh, Ashraf is the
Okay.
All right.
Thank
Thank
you so
Right.
much.
you.
Bye.
Thank you. Good night. Bye bye.
Bye bye.